We're going to do our second example using the limit definition of the derivative at a point to find the slope. It will all make sense. So the problem is asking us to find the slope of the function at x equals 3. The general definition for the slope is the derivative of g at a point A is the limit as h approaches 0 of g of a plus h minus g of a over h. Because we want to do this at a equals 3, we really want to find the derivative of g at 3, which becomes the limit as h approaches 0 of g of 3 plus h minus g of 3 all over h. So let's do this here on the side. G of 3 plus h is going to be what? We replace 3 plus h everywhere we see x in the function. So here we replace by 3 plus h, so it's 3 plus h divided by, for this x, we replace 3 plus h again and leave the negative 2 there, and then combine the two numbers. So g of 3 plus h is 3 plus h over h plus 1. H plus 1. And because the point 3, 3 is on the graph, that tells us that g of 3 is 3, because that point is of the form 3 g of 3. We're ready to replace in our function. So the derivative of g at 3 is going to be the limit as h approaches 0, g plus 3h is this, I'm going to replace it there, is 3 plus h over h plus 1, and replace g of 3 equals 3 here, minus 3, and this is all over h. Now we do our rational expressions, and we multiply and divide here by h plus 1 over h plus 1 to make them have a common denominator. And this becomes the limit as h approaches 0 of 3 plus h minus 3 times h plus 1 all over h plus 1 and then all over h. Now, recall that when you have a complex fraction, there's a 1 down here. You keep the top. I'm going to keep the top. I'm only going to distribute that 3 there, that negative 3. So that's 3 plus h minus 3h minus 3. So we keep the top and multiply by the reciprocal of the denominator. So next I'm going to combine, so h approaches 0. The 3 cancel out, and h minus 3h is negative 2h. And then when multiply the denominators, we get h plus 1 times h. The h's cancel out, and we get the limit as h approaches 0 of negative 2 over h plus 1. When we take the limit and replace h by 0, this approaches 0, and my limit is negative 2. So this is the slope of the tangent line. Now we can state our answer properly and say the slope of the function at a or x equals 3 is negative 2. So this gives us the slope of the tangent line at x equals 3.